Hello, everyone, and welcome to Paperledge, the show that unearths cutting-edge academic research and dusts it off for everyday life. I'm Ernis, your host. Today, we're diving deep, really deep, into a new paper that's redefining how AI hears and understands the world around us. Now, picture this. You're standing in a bustling marketplace, sounds swirling around you, vendors hawking wares, children laughing, a street musician strumming a guitar. Our brains, those incredible organic computers, effortlessly sort through this sonic chaos, pinpointing the source and meaning of each sound. But what about AI? Can it do the same? Not quite yet, but this paper is a huge leap forward. We're looking at Star Bench, probing deep spatio-temporal reasoning as audio 4D intelligence. Yes, it's a mouthful, but the core idea is simple. Existing AI models are pretty good at understanding what sounds are, but not so great at understanding where and when those sounds occur in space and time. Think of it like this. They can tell you there's a dog barking, but can they tell you the dog is getting closer? That's the 4D intelligence we're talking about. Sound plus space plus time. Now, the authors, a brilliant team from Beihang University, Shanghai AI Laboratory, Shanghai Jiao Tong University, and the Chinese University of Hong Kong, argue that current audio benchmarks primarily test semantics that can be derived from text descriptions, overlooking the nuances of fine-grained perceptual reasoning. So, they've built Star Bench to address this gap. Let's step into our memory palace, shall we? Imagine a vast concert hall. The first room is the foundational acoustic perception chamber. This is where the authors drill down on 6 core audio attributes: pitch, loudness, duration, azimuth, elevation, and distance. Azimuth and elevation, those are fancy words for horizontal and vertical angles. Think of it like plotting a star's position in the night sky, but with sound. The twist? They test these attributes under both absolute and relative conditions. Can the AI identify the exact loudness of a sound, and can it tell if one sound is louder than another? It's like teaching a robot to appreciate both the note and the nuance of a musical performance. And here's where things get really interesting. They use procedurally synthesized audio and physics-based simulations to create high-quality, controlled samples. This means they're not just relying on real-world recordings, which can be messy and unpredictable. They're building their own sonic Legos. Now, let's move down the hall to the holistic spatio-temporal reasoning room. Ready for some mental gymnastics? Here, the tasks get much more complex. The AI has to deal with things like segment reordering, static localization, multi-source relations, and dynamic trajectories. Translation: can the AI figure out the correct order of a series of sounds, pinpoint the location of a sound source, understand the relationships between multiple sound sources, and track the movement of a sound source over time? Imagine this scenario. You hear a series of sounds: a door creaking open, footsteps approaching, and then a voice whispering, "Psst, I know where they hid the cookies." Can the AI piece together this sonic puzzle and tell you what's happening? That's the kind of reasoning Star Bench is designed to test. But wait, there's more. The authors use a rigorous 4-stage data curation pipeline that includes human annotation and final selection based on human performance. This ensures the benchmark is not only challenging but also ecologically valid. They're making sure that the AI is learning to hear the world as humans do. So, what happens when they pit 19 different AI models against Star Bench? Well, let's just say the results were illuminating. The authors found a clear capability hierarchy. Closed-source models, like Gemini 2.5 Pro, excel in knowledge and reasoning but are bottlenecked by fine-grained perception. Open-source models, on the other hand, lag across perception, knowledge, and reasoning. This suggests that current AI models still have a long way to go before they can truly understand the nuances of our auditory world. And Star Bench isn't just a test, it's a roadmap. The authors highlight several key insights for future development: enhancing dense audio captioning, improving multi-audio reasoning, and moving beyond channel-averaged audio preprocessing. In other words, we need to teach AI to listen better. reason smarter, and pay attention to the spatial information encoded in multi-channel audio. Fine, yeah, I guess. Look, the point is, this paper is a big deal. It's not just about building better AI. It's about building AI that can better understand and interact with the physical world. Think about the implications for robotics, virtual reality, and even assistive technologies for the visually impaired. And that, my friends, is where the future of audio AI is headed, toward a more robust, nuanced, and human-like understanding of sound. So, the next time you're surrounded by the cacophony of everyday life, take a moment to appreciate the incredible complexity of sound and the amazing ability of our brains to make sense of it all. And remember, the journey to build AI that can do the same is just beginning. That's all the time we have for today. Thanks for joining me on this sonic adventure. For Paperledge, I'm Ernis, always eager to explore the latest frontiers of knowledge. Until next time, keep listening, keep questioning, and keep exploring.